Okay, this is MAT 175, Lesson 25, Section 6.3, Properties of Trigonometric Functions. And we're going to determine the domain and range of trigonometric functions. Here we have sine theta. We know that sine theta equals to y, and we know that sine can basically move 360 degrees over and over and over again. So there's no breaks in the sine function. So sine is continuous. We know that sine normally follows the y coordinate, and cosine normally is placed in for the x coordinate. Again, cosine can move around and around and around. Cosine is not undefined in any place, so cosine basically can become is continuous. Now, for tangent, if, for example, if tangent, we know that tangent here is at 0 degrees, for example. We know that sine, we know that tangent is equal to sine at 0 degrees over cosine at 0 degrees. And here we have cosine and sine. So sine is 0, has a value of 0. Cosine has a value of 1. So we can say that tangent is 0 at 0 radians or 0 degrees. Whereas up here at pi over 2, for tangent at pi over 2 or 90, we would have sine pi over 2 over cosine at pi over 2. And so if we look at cosine and sine, we can see that sine at pi over 2 is 1, but cosine is 0, so tangent is undefined. So tangent cannot have a 0 in the denominator. So at pi over 2 and 3 pi over 2, tangent is undefined. For cosecant, cosecant again cannot be 0 where have a 0 in the denominator. So anywhere where sine is 0, cosecant is undefined. So here at 0, sine is 0. So cosecant would be undefined here. And at pi, this would be cosecant at pi is the same thing as 1 over sine pi. Well, sine at pi is 0, so cosecant must be undefined at pi, and cosecant is also undefined at 0. And now secant is going to be undefined. Cannot have 0 in the denominator. So since secant is the reciprocal of cosine, if we put cosine theta anywhere where cosine is 0, secant is going to be undefined. So cosecant is going to be 0 at pi over 2 and at 3 pi over 2. So cosecant is going to be undefined at pi over 2 and 3 pi over 2, because that's where cosine is 0, at pi over 2 and 3 pi over 2. Okay, and then cotangent is going to be undefined where sine is 0, because sine is the same as y. And so cotangent is going to be undefined at 0 and at pi, because that would be, because if we looked at it like this, this would be cosine over sine theta, and so at 0 cosine is 1 and sine is 0. So cotangent is undefined at 0 and also at pi, because that's where sine would be 0 there as well. Okay, and so we are given the domain and range for our 6 trigonometric functions, which we just went over. Alright, and when we get into graphing, you will see why the range for sine and cosine is between -1 and 1, and tangent is all real numbers, and so on. Well, when we get to graphing, we'll get more into the range part. Okay, determine the period of the trigonometric functions. Okay, now we know that in the unit circle, 1 revolution is 2 pi. So if we go 1 revolution and then to, let's say, pi over 3, then we would say that these angles are coterminal. So in this case, we could say that pi over 3 and 2 pi plus 2 pi, so if we need a common denominator, we have to multiply 3 over 3. So that'd be pi over 3 plus 3 times 2, that would be 6 pi over 3. So that'd be 7 pi over 3. So one whole time around and then some, this would be 7 pi over 3. And so that would be 2 pi plus pi over 3 is 7 pi over 3. And so we could say that pi over 3 and 7 pi over 3 are coterminal angles. They share the same functional values. And so if we were to subtract 7 pi over 3 minus 2 pi, we would get pi over 3. And so we would use the values for pi over 3, because the values are the same for 7 pi over 3 as they are for pi over 3. And so for this angle, we would say that this looks similar to 120 degrees. It doesn't say it's 120, but we'll call it 120 degrees. So if we were, so this theta here, this would be 120 degrees. So now if we were to go 1 whole revolution around and then 120 degrees, that would be 360 plus 120, and that would be 480 degrees. So we could say that 480 degrees and 120 degrees are coterminal with each other. They share the same functional values. So we could say that these values here, this would be -1/2 and a positive square root 3 over 2. And so 120 would have these values for cosine and sine, and so would 480. And so if we were to subtract 360 from 480, we get 120. We can use the values for 120 to find the values for 480. And you could also use the same thing for radians as well. Okay, so we can say that sine theta plus 2 pi times k, where k is the number of times that you go around in a unit circle. So if you go around 1 time, then k is 1, and just be 2 pi. If you go around 2 times, then it'd be 2 times, that would be 4 pi. And so it'd be 4 pi plus an angle. And then if you go 1, 2, 3, that would be 3 times 2, that would be 6 pi. So each time you go around 1 whole revolution, that's an increment of 2 pi. So that would be 2 pi, 4 pi, 6 pi, 8 pi, and so on. And same thing for cosine. So if you were to take the number of revolutions, and that would just be, you back to where you started from, then you could just use what was left over as your values. And we'll get into how that works when we work through our problems. Okay, so a function of f is called periodic. There is a positive number p such that whenever theta is in the domain of f, so that theta plus p. So we're looking at this 2 pi k here. That would be your p, the number of period of times that you would go around the unit circle. And so that you would use the smallest value, since the angles are coterminal. We said before that the angles were coterminal, and so you would just use the smallest value because they're always going to be the same. Now, so that's all, and all this is saying is that since sine and cosecant are reciprocals of each other, that's going to be the case. If cosine and secant, they're reciprocal identities. Now for tangent, it does not, you don't use 2 pi, you only use 1 pi for tangent and cotangent, because tangent and cotangent, their periods are going to be the same from theta to pi. And so, for example, for pi over 4, tangent is 1. And for 5 pi over 4, you're going to have that negative square root 2 over 2 or negative square root 2 over 2. The negatives cancel, and you still get 1. So the period is only 1 pi for tangent and cotangent. And that's going to be always true. Okay, find the exact value for sine of 17 pi over 4. So basically, you're going 1, this would be 2 pi, 4 pi. Okay, so we're looking at this 1 revolution here. This is pi over 4. Well, if we keep going here to pi, this would be the same thing as 4 pi over 4. And if we keep going to 2 pi, that's the same thing as 8 pi over 4. So if you want to look at this in terms of increments of pi over 4, we can look at this as 8 pi over 4 times 1 time around. That's still just 8 pi over 4. So 8 pi over 4 times 2. 2 times 8 is 16. So that'd be 16 pi over 4. And then 8 pi over 4 times 3 times around. That'd be 8 times 3, that's 24 pi over 4. And then we'll do one more, 8 pi over 4 times 4. 8 times 4 is 32 pi over 4. So each time you go a whole revolution, and as long as you don't go past the next one, then that's the angle that you're going to use. So here we have 17 pi over 4. So if we took 17 pi over 4 minus 16 pi over 4, we get 1 pi over 4. So that would be the same thing as sine at pi over 4. So if you look at it on the unit circle, down and then back to pi over 4. So we would say that would be 17 pi over 4. And so the values there are still square root of 2 over 2, square root of 2 over 2, for cosine, sine, tangent is 1. And so in this case, the answer is going to be square root 2 over 2. Alright, now let's look at cosine at 5 pi. So here we have our increments of 2 pi 4 pi, 6 pi. So basically we're looking at 5 pi, cosine at 5 pi minus 4 pi, and we get 1 pi. So really this would be the same thing as if we were to say cosine at 1 pi. Well, cosine at 1 pi is negative 1, 0. For cosine and sine, we would say cosine at pi at 5 pi is the same as cosine at pi, and so that would, the value with that for that would be negative 1. Okay, now for tangent, we are going to go in one increment. So here, tangent at 5 pi over 4, if we look at, here's 4 pi over 4, so tangent at 5 pi over 4 would put us in quadrant 3. And so that's negative square root 2 over 2, negative square root 2 over 2 for cosine and sine, and tangent is going to be a positive 1 because it's negative square root 2 over 2 over negative square root 2 over 2, and so we get a positive 1. So tangent at 5 pi over 4 is going to be just 1. And that's what we get. And that's what we did here. Alright, so determine the signs of the trigonometric functions in a given quadrant. Okay, so here we have, now these signs are always the same as what we've looked at for x and y. Only now, instead of x and y, we're looking at them in terms of cosine and sine. So now we're looking at them in terms of cosine and sine. Cosine and sine, cosine and sine, cosine and sine. So we could say that cosine is negative in quadrant 2, and sine is positive, and so on. And so if, in this case, if sine is positive, its reciprocal cosecant is also going to be positive. Here, cosine, and so we would say here that cosine theta is negative, and so its reciprocal secant is also negative. Secant theta is also negative. And so the same thing, since tangent is going to be sine over cosine, it'll be negative over negative. Tangent will be positive, and so will cotangent. And so our identities and the reciprocals are going to be the same signs. Okay, so those are the signs. So now we can use that to help us to solve problems. So we want to find the quadrant where sine is positive. If we're looking at sine is positive, so sine is positive, since sine, cosine, sine is positive, so that means the y values are positive. So we're looking at either quadrant 1 or quadrant 2 for sine being positive. Now cosine is negative. Well, cosine is like x. Well, x is negative in quadrants 2 and 4 and 3. So here, sine is positive in quadrants 1 and 2, and cosine is negative in quadrants 2 and 3. So we look where the two intersect, and so where they're the same. And so we would say we're looking at the angle lies in quadrant 2. And so that's what that explains. Find the values of the trigonometric functions using the fundamental identities. Okay, we know that cosecant is reciprocal of sine. And so secant is reciprocal of cosine, and cotangent is reciprocal of tangent. So we can use that to help us to solve problems. And we know that tangent is sine over cosine. So there, since cotangent is reciprocal, cotangent is going to be cosine over sine. Okay, so we're given here that sine theta is square root 10 over 10, and cosine theta is 3 square root 10 over 10. Find the values of each of the 4 remaining trigonometric functions. Well, what we do here is we start off with sine theta is square root 10 over 10, and we have cosine theta, and that's 3 square root 10 over 10, and then we put here tangent, and we know that what's the reciprocal identity for sine? You should have said cosecant. Cosecant, and then what's the reciprocal for cosine? You should have said secant. And then cotangent is the reciprocal for tangent. So for tangent, you're going to use sine over cosine. So that'll be square root of 10 over 10 over 3 square root 10 over 10. And remember we said before that a over b equals to a divided by b equals to a times the reciprocal of b. So basically what we're doing is we're taking this denominator, and we'll go ahead and work through this long ways. This will be square root 10 over 10 divided by 3 square root 10 over 10. So we're going to take the second term and apply the reciprocal and multiply. So this would be square root of 10 over 10 times 10 over 3 square root 10. And now we want to simplify. So the 10s, they can cancel, they simplify. The 10s, they go out, they simplify. And so what we have left is, since square root of 10 goes into square root of 10 once, square root of 10 goes into itself once, and 10 goes into 10 once, 10 goes into itself once. We get 1 times 1 is 1, 1 times 3 is 3. So we end up with 1/3. Well, if tangent is 1/3, then what do you think cotangent is going to be? Well, cotangent is going to be the reciprocal of tangent. Since tangent is 1/3, cotangent is going to be 3 over 1, or just 3. Okay, so now let's take a look at cosecant. Cosecant is reciprocal of sine. So that means cosecant is going to be 10 over square root of 10. So all we did was apply the reciprocal to sine. And we can't leave the radical in the denominator because that's not simplified completely, so we have to rationalize the denominator. So we have to apply square root of 10 over square root of 10. And so we get 10 square root 10 over 10 times 10, that'll be square root of 100. Square root of 100 is 10. And so the 10s can go into 10 once, 10 goes into itself once, and we end up with just the square root of 10 for cosecant. Okay, for secant, we apply the reciprocal of cosine, since secant's reciprocal identity of cosine. And what do you think this will be? You should have said 10 over 3 square root 10. Well, what do you think we have to do at this point? You should have said we have to rationalize the denominator. And so how do we rationalize the denominator? You should have said we apply the square root of 10 over the square root of 10. And so this will be 10 square root 10 over 3 square root 100, right? Because 10 times 10 is 100. Well, the square root of 100 is 10. So that's going to make this 10 square root, do this black, 10 square root 10 over 3 times 10. And so that's going to make 30. Well, the 10s here can cancel, right? 10 can go into 10. We don't even have to multiply. We can just just simplify the factors of what we have in the denominator. And so we end up with square root of 10 over 3. And so that's the value for secant. Okay, and so that's what we did here. We got tangent is 1/3, cotangent is 3, cosecant is square root of 10, and so on. Okay, the equation of the unit circle. Well, we know that the equation of the circle is x squared. Since we're looking at the circle at the origin, then this would be, and the radius is 1, because the unit circle, our unit circle has a radius of 1. This is x squared plus y squared equals 2r squared. Well, we know that, what do you think is synonymous with x? It's cosine, and synonymous with y is sine. So they just switched them around. Instead of putting, this would be like saying y squared here plus x squared here equals 2, r squared. So this, we know that since sine is synonymous with y, then it's sine squared theta. And then x is synonymous with cosine, so x squared is going to be cosine squared equals 2r squared is, well, 1 squared, that's just 1. So we can say that sine squared theta plus cosine squared theta equals 1. And we can use that to help us to solve problems. Now if we took that sine squared theta plus cosine squared theta equals 1, and we divided cosine squared theta into each one. So we divide cosine squared theta, divide cosine squared theta, divide cosine squared theta. And so sine over cosine is tangent. So sine squared theta over cosine squared theta is tangent squared theta. Well, cosine squared theta over cosine squared theta, that's 1. And then 1 over cosine squared theta, if 1 over cosine is secant, then 1 over cosine squared theta is secant squared theta. So we can say that tangent squared theta plus 1 equals to secant squared theta. Now, again, let's do this again. Here we have sine squared theta plus cosine squared theta equals 1. And now this time, we're going to divide everything by sine. So here's sine, divide by sine squared theta, divide by sine squared theta, divide by sine squared theta. Okay, so basically what we're doing here is you can do anything as long as what you do to one side, you do to the other side. So we go ahead and we can algebraically we can do this. So sine squared theta over sine squared theta is 1. Cosine squared over sine squared, that's cotangent squared theta. Cotangent. Cotangent squared theta, and 1 over sine squared theta, well, 1 over sine is cosecant, so 1 over sine squared theta is cosecant squared theta. I'm trying to squeeze that theta in there. And so we use these, what we call the Pythagorean identities. And these identities here will become critical for us later on in our lesson. So that's what they showed here. Okay, and so our fundamental identities, we've already looked at tangent, cotangent, and our reciprocal identities, and our Pythagorean identities. So we're building on this, and you need to commit these to memory. So if you have to get flashcards for them, you want to do that. Okay, use EvenOdd Properties to find the exact values of the trigonometric functions. Alright, now, when we know that if we work our problems counterclockwise, our angles are positive. Well, if we move our angle in a clockwise direction, our angle is negative. For example, if we have here, let's say theta is 30 degrees, then if we were to go in a clockwise direction, this would be negative 30 degrees. Or in this case, this looks more like 60, so we'll use that. And then, so this would be theta were 60 degrees, and this would be negative 60 degrees, and so on. But it doesn't have to be 60. I just use 60 because it looked closer to 60 degrees. With the even-odd properties, when we have sine of a negative theta, then that equals to negative sine theta. In other words, if we have sine of a negative 30 degrees, that would be the same thing as if we were to say negative sine 30 degrees. Well, sine, if we're looking at 30 degrees, square root of 3 over 2, 1/2 for cosine and sine. Sine is going to be, sine is 30 degrees is 1/2, but we have a negative in front, so that'd be negative 1/2, and so on. Cosecant, since it's the reciprocal of sine, the same thing's going to apply there. Now, cosine is different. Cosine, when you have a negative theta, is equal to positive cosine. So if you have a negative angle, you get a positive cosine. So if we have, for example, cosine of a negative 30 degrees, that would be the same thing as if we were to say positive cosine of positive 30 degrees. And cosine 30 degrees is square root 3 over 2. Tangent of a negative theta is going to be negative tangent. Same thing with cotangent. Well, since one more thing here, since secant is the reciprocal of cosine of negative theta is positive cosine, then secant of a negative theta is also going to be positive secant.